Hi everybody, it's Mr. Holding here, and this quick video is looking at how we use Punnett squares to interpret what we looked at last lesson. So last lesson we looked at pedigree charts, and we worked out how to get to this situation here. So we analysed the pedigree, and we came up with a scenario where Samantha Smith has a 1-to-1 chance of having sickle cell anemia. All right, so we're going to take that over to our working here. So here is our potential cross here between Johnny Bravo and Samantha Smith. So we're going to give Johnny Bravo a 1:2:1 chance of having big B, twice the chance of being a carrier, and then a single chance of being having the disease. And in this case, we're looking at sickle cell anemia. Okay, so what we want to do here is you want to cross these two. Okay, and if you've seen the video on complex Punnett charts, you should have an idea of what to do. So if we put, what we're going to do is we're going to lay out a chart putting Johnny Bravo at the top and Samantha Smith down the bottom. Now remember, because this one here is 2 to this 1, it has to be represented twice as much. Okay, so I've gone ahead and done that. Okay, and I put Johnny Bravo up the top. Okay, big B, my 1, big B, little b, and I've put that twice. So once here and once here. So that's my 2 and 1 little b here. And Samantha Smith, it's a 1:1, so they have to just be represented the same. So big B, little b there, and then little b there. Okay, just like we've got here. All we then need to do is go in, fill them in. So I've gone and filled them in now. Okay, and now I want to work out the fractions and percentages for each of them. So first of all, I need to count 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7, 8. 4 8s are 32. So they're going to be out of 32. And then I need to go and count each of these and work out my fraction. So having done that, I've counted them all up. I've got 4 out of 32, which is the homozygous dominant. I've got 16 of them are heterozygous, and 12 out of 32 would be homozygous recessive, which gives us 12.5%, 50%, and 37.5%. So what this allows us to do, what this basically says, is if I cross these two parents, mum and dad, I've got a 12.5% chance of having homozygous dominant. I've got a 50% chance of them being a carrier, or heterozygous dominant, and I've got a 37.5% chance of this particular mix ending up with offspring that has the recessive autosomal condition, which is sickle cell anemia. Okay, you need to now go and do these three. You need to do this 3 separate times for the 3 separate fathers. Okay, and you'll end up with 3 sets like this. You can then go and compare them with each other and make a decision based on your percentages to work out which father is going to end up with the offspring with the least chance of having PRA in the case of dogs. In this case, it's obviously with sickle cell anemia. Well, I hope you found this helpful. Good luck with it.